Hello again. Welcome to Maths is Not a Mystery again. We are looking at converting from decimals to fractions today, and we're doing the higher level section, which is all about recurring decimals. Recurring decimals are decimals that keep on repeating and never come to an end. And when you convert those into fractions, it's a little bit more complicated than the original version that you might have learned at the lower levels. So let's take a look at how we do it. We'll start with this fraction here, 0.66666 forever. It can be written as 0.6 with a dot over the top of it, and that dot means that obviously that number is there, going to be recurring forever. How do you do this? Okay, so what you do is we create a little thing. Let's let x equal 0.6666. And we need to find a way to bring a number, a digit, over the decimal point so that it becomes a whole number and still have the recurring numbers at the back. Now, the easiest way to do that would be to just create this, which would mean timesing it by 10. If we multiply it by 10, we move that 6 over there. The other 6s still carry on being decimals. So 10x, 10 lots of x, is 6.666. And what we do then is we take this and we take our 10x, which is 6.666, and we subtract our 1x, which was 0.666, and the answer to that question leaves us with 9x, 10x take away x, which leaves us with 6.0, doesn't it? Because all those other 6's disappear. Now that means if 9 x's make 6, then 1x must be 6 divided by 9. And that's it, that's completed. We can of course simplify that, because we can divide both of those by 3 and make it 2/3. Not going to concern ourselves too much with the simplifying because that's easy work. It's more really related to how we arrive at the thing that needs simplifying. Alright, so that's how we did that. We multiplied it by 10 so that we brought one of the 6's over the point, and then we did the 10x's, take away the original 1x, and then we just come to a division. If you've got more than one number repeating, 0.7272 recurring, then it's going to be slightly different, because we're going to start off the same. We're going to let x equal 0.7272, as we said there. But then we need a situation where we can have a whole number over on the first, in the front of the point, and then we need the same pattern repeating behind the point. Now the pattern is 727272. So what we really need here is 72.7272 and so on. To do that, we've had to multiply by 100, haven't we? We'd be multiplying by 10 to get the first 7 across the point, and then by 100 to get that first 2 across the point. So 100x makes 72.727272. Now, following the pattern that we had up here, it's the same sort of idea. So we do 100x, which was 72.7272, minus the original x, which was 0.7272, and that leaves us with 99x equals 72, and those obviously disappear. So that means that x is 72 over 99. And obviously, if they're possible to simplify after that, then we carry on and we simplify them. So that one was multiplied by 100 because we had to move 2 numbers back over the decimal point. Now, following that same pattern, we're not going to keep on going until we've finished the entire list of possibilities off, but here we've got 3 numbers that would have to move over the decimal point. 0.145145. So once again, we're going to let x equal 0.145145, and we need 145.145145. So that means we're going to be multiplying it by 10, 100, 1000. So 1000x equals 145.145145. So again, we follow that same pattern off. 1000x, I'll just do a short little bit there, minus the original x, which was 0.145. And that's going to leave us with 999x equals 145.0, which means that x itself is 145 over 999. Once again, always look out to see whether you can simplify it after that. Okay, so far what we've looked at there are numbers that are complete recurring. It's a group of numbers that fully recur the whole time. Now sometimes it doesn't quite work out like that. Take a look at these. What we've got here this time, look, on this first one, is we've got 0.3282828. So we've got a recurring decimal, but we've got this rogue number at the front. And that's got to be got rid of somehow. We've got to include that into the system, and that means that it's going to be a little bit more complicated to deal with this one. So what we're going to do is we're going to say that x equals 0.32828 and so on. To get that 3 across the decimal point, we need to multiply by 10. So that's 3.2828. But if you remember before, we also tried to get some of the numbers that were in the recurring pattern over the decimal point. And the numbers we'd have to get across the decimal point would be the 2 and the 8. So we've already multiplied by 10 to get the 3 across. Multiplying by 100 would get you the 2 across. Multiplying by 1000 would get you the 8 across. So we can actually say here that 1000 lots of x would be 328.2828, etc. And what we do this time is we take our 1000x, which equals 328.2828, and we take our 10x away from it. That was 3.2828. Now that gives us a different answer here. 1000 take away 10 is 9,990, isn't it? It's 990. I do apologise. 990 x's. 328 take away 3 is 325, and all of those 2 8s disappear. So what we end up this time with is 325 over 990. That clearly is possible to simplify, because both of those things can at least be divided by 5. I'm not going to do that right now though, because you can do simplifications for yourself. It's getting to this point that matters. One more, it's the same kind of idea, but this time 0.5142142142. This is going in groups of 3. So we've got this rogue 5 at the front, and then we've got 142, 142, and we're going in 3s. So follow the pattern, which I hope you're becoming familiar with by now. X is what we started with, 5, 142, 142. We can bring the 5 over the point by multiplying by 10. So it becomes 5.142142. So what we've done there is we've cleared away the number that's spoiling the pattern. We've made that into a whole number so that just the pattern remains behind the decimal point. And then we need to bring the first section of the pattern over the decimal point. So what we want is 5,142.142. So that means we've already multiplied by 10, be 100, 1,000, 10,000, 10,000x. 10,000 lots of x makes that. And then, following what we did before, we're going to get our 10,000x, which equals 5142.142. We're going to subtract 10x, which was 5.142. Okay, this time 9,990x equals, those 142's disappear, 5,142 take away 5 is 5,137, and so x is going to be 5,137 over 9,990. I don't think that's probably possible to simplify, but again, we've got to the place where we need to be to gain the vast majority of marks. So that's how you move a recurring decimal into becoming a fraction. Okay, there's more slow information about that in the Maths is Not a Mystery book about fractions and decimals. I hope that's been useful. Thank you for watching, and we'll see you again soon. Goodbye.